So to start us off, we need to appreciate what the mole is. Okay, the definition you need to know is that it's defined as the number of atoms in exactly 12 grams of carbon-12. Okay, so no other isotopes other than carbon-12. Now this number of atoms is actually this value here, so 6.022 times 10 to the power of 23, and this is called Avogadro's number. Okay, so expressed out fully, that's the amount of atoms here. And this is just a little image, okay, to show that 1 mole of sand grains, okay, if we were collecting sand grains as opposed to atoms, would stretch for 1 mile or 1.6 kilometers. It's the equivalent, okay, so it's an amount of substance, a unit, equivalent to what maybe a baker is calling a dozen, okay, as being 12, or just as we call in everyday use, a pair, 2. To calculate mole type questions, okay, we can use this equation here, number of moles, so N equals mass M over mR. Okay, mass itself, and this equation here can be used in these equation triangles. Okay, so mass there, we know the units, okay, are going to be grams or kilograms, depending on how large a substance you're using. Number of moles, N, okay, is just given the unit moles, and then molar mass, or MR, okay, is given the units grams per mole or kilograms per mole if you're using quite a lot. So we can use this relationship here that we found out to work out some calculations, okay, of the number of moles. So this basically equates to N equals M over mR, and the question given here is calculate the number of moles of oxygen molecules in 4 grams. Now, we know that oxygen molecules exist as O2, and that each oxygen, okay, from the periodic table has a relative atomic mass of 16 grams per mole. So it's a simple calculation of 2 times 16 grams per mole, okay, equals 32 grams per mole. So right now we already know, okay, the MR must link here. Now the mass, which is given in the question, is 4 grams, so that will appear here. So it's quite easy. Number of moles equals 4 grams divided by 32 grams per mole, which a quick calculation gives 0.125 moles. We can also use this equation triangle in order to work out mass if we are given a molar mass and the amount of a substance in moles. So for example, if a question was asking what is the mass of 0.25 moles of sodium carbonate, we could work this out by first of all working out the relative molecular mass, Mr, of sodium carbonate. So that is 2 times 23 grams per mole plus 12 grams per mole for the carbon, and then plus 3 times 16 grams per mole for the oxygen. So this would equal 106 grams per mole. And now all we need to do is input it into our equation. So we've worked out the molar mass, the MR. We've been given in the question the amount of substance, 0.25 mole. So really it's quite easy to work out the mass. Mass equals 0.25 times 106. Okay, so that would give us 26.5 grams. This just leaves the last calculation that you can do with this triangle, okay, is to calculate the MR, the molar mass, and this is the units grams per mole minus 1, okay, and all that is using the other two terms, so it's mass divided by an amount of substance. We won't go through a calculation here because you can see from the other two exactly what you'd be doing. Okay, so you've just got to extract the mass of the substance and then the amount of substance in moles and just put it into the equation. So we can use what we've learnt from the previous slides and the equation N equals M over MR, so number of moles equals mass over the molar mass in many different questions. We're just going to look at this question here. So calculate the mass of carbon monoxide needed to produce 11.2 grams of iron from the reduction of iron oxide. Now the equation they've given below, okay, so this is balanced and we can use these ratios later. So step 1 is going to be working out the number of moles in 11.2 grams of iron. So we can use our equation, number of moles equals M over MR. Input M here with the 11.2 grams, and MR is just going to be our relative atomic mass for iron. Okay, so if we input the correct values there, that's 11.2 grams, as shown here. And then iron, if we looked up on the periodic table, is going to be 55.8 grams per mole. If you do that calculation, you're going to end up with 0.2007 moles. Step 2 is using this value that we've got here, so we know there's 0.2007 moles of iron on this side. The question is asking us to calculate the mass of carbon monoxide needed. This carbon monoxide is shown, okay, in our equation here. So we can use the ratios that 2 iron gives 3 carbon monoxide. As you can hopefully see, we can simplify this, okay, by dividing both sides by 2. This gives us an easier ratio to work with, so 1 iron gives 1.5 carbon monoxide. Now, step 3 just involves using what we've calculated in our first bit, whereby we've worked out the number of moles in 11.2 grams of iron being 0.2007. So we can input that onto our iron side, okay, and so to work out the amount of carbon monoxide, we just times it by 1.5, just like the ratios show. So that will give us 0.3011 mole. Now this then means, so this is the number of moles of carbon monoxide. This then means we have to still finish off calculating the mass. So step 4, we just rearrange N equals mass over MR to make mass the term. So that equals mass gives number of moles times MR. Okay, we've worked out number of moles here in this section, so we can input that here. And then times the MR. Now the MR is just going to be, okay, the sum of a carbon and an oxygen. So this obviously is 28, so we just times the two together and then we end up with the answer 8.43 grams.